In this section, we'll learn about matching file names using path name expansion. The objective of this section is to make sure that you can more efficiently run the commands we like to use on the command line interactions using the substitution and expansion methods available to you in a bash shell. The bash shell has a number of ways to help make your work more efficient, the first of which is known as pattern matching. We have a number of ways to express globbing or wildcard usage that allows us to express in the bash shell ways to shortcut and identify multiple files with some simple syntax. Have a look at the following table on meta characters and matches. We'll use many of these in the terminal in just a moment, but let's take a quick look at the various ways we have to annotate our interactions on the command line to take advantage of pattern matching. One of the foremost characters we use in pattern matching is an asterisk, otherwise known as a star. When we say star or substitute that with an asterisk, that means that we will replace this particular piece of the pattern with any number of 0 or more matching characters. If you recall from our previous guided exercise, we had a number of files numbered 1 through 6. We could substitute in place of each of those numbers an asterisk character to denote any of those files. We'll see that when we get to the command line with this. A question mark character allows us to replace any single character with a wildcard here that specifies that any character can be used in its place. This does require that a character be in that place, unlike the asterisk above. This must be replaced with any single character. We then get into a number of bracketed annotations, the first of which shows the example of single brackets and some characters in between. Any one of the characters designated within the brackets can be used to substitute the character in its place. Additionally, by adding an exclamation point to the beginning of this expression, we're changing the meaning from this to be any of those characters to it can be any of these any character except the ones we list within the brackets. The exclamation point or bang is like a not operator. So this bracketed annotation would mean not A, B, or C. We can see other single bracketed expressions that give us an annotation, such as the caret symbol that gives us the annotation that means must start with this character. We can see double bracketed annotations that means some other shorthand keywords. When we say alpha in the double brackets enclosed within colons, we mean that any alphabetic character can be substituted in place there. Lower means that this character must be lowercase. Upper obviously means that it's uppercase. Alnum or alphanumeric means that it can be any alphabetical or numerical digit. PUNCT or punct says that the printable character can be anything that's not a space or an alphanumeric character. Digit comprises the numbers 0 through 9. And lastly, the space keyword says that a single white space character can be used. This means that it could be a tab, a new line character, form feeds, or spaces themselves. Here we can take a look at a few examples in the command line. Let's duplicate this work by jumping back into the terminal. Let's create our working directory. All right, I'm going to make a directory that I'll call glob and cd into the glob directory. I'll clear my screen to begin the work. We can see in the instructions here that they create a number of files: Alpha, Bravo, Charlie, Delta, Echo, Able, Baker, Cast, Dog, and Easy. I'll use a touch command to do the same. Now that I've completed that command, you can see in the listing that I have all of those files. Now that we want to start using some of our pattern matches, let's start with the ls command to list out all the files that begin with A and use the wildcard asterisk to do so. If we say ls a star, we get both files, Able and Alpha. Now, if I say LSA and I use 3 question marks to denote that 3 characters must be there, this should only match the one that is 4 letters long. And indeed it does. If I were to add an additional question mark, I then get Alpha. As you can see, the asterisk allows us to replace any number of characters as a match, whereas the question mark must match a single character in that place. Now let's use a bracketed annotation to do some similar work. We'll look at the A and C words that begin with A or C, meaning that the first letter, first character, can be A or C. When we now say asterisk after that, then it's any number of characters to follow. This gets us all 4 of the words Able, Alpha, Cast, and Charlie. If we were to restrict the number of characters in there using the replacement of asterisk to question marks, we could see something similar as we saw before, which is that we would start with the letters A or C and then followed by 3 individual letters. This only matches Able and Cast. If we just wanted to match on question marks alone, all the 5 character words, we could put 5 question marks and see that we have only the 5 lettered words that show up.